Hello, welcome to our channel Learn to Score. In this video, I am going to explain what is completing square method and show how to find roots of a quadratic equation using completing square method. This is part of quadratic equations chapter of 10th class mathematics. I hope you will like the video. Please subscribe to our channel for regular updates. Thank you. In the previous video, we learned about finding roots of quadratic equation using factorization method or split the middle term method, right? Now I have a question for you. Can you find roots of x square plus 5x plus 3 equal to 0 using the factorization method you have learned in previous video? We know that in the factorization method, we have to find two numbers p and q such that p plus q is going to be equal to coefficient of x. In this particular case, it is going to be 5 and PQ is equal to product of remaining coefficients, right? What are the remaining coefficients? 1 and 3, right? Their product is equal to 3. It means we have to find two numbers P and Q such that P plus Q is equal to 5 and PQ equal to 3, right? So to find that numbers, what we do is we first start with factors of number 3, right? What are the factors of number 3? 1 and 3. Right? So I can write 3 as 3 times 1. So their sum is 3 plus 1, that is equal to 4. We want P and Q such that P plus Q equal to 5, right? Whereas here we got 4. It means this is not the right choice, right? So 3 can also be written as minus 3 times minus 1. And their sum is minus 4. This is also not equal to 5. That's why this is also not a choice. But we said that factors of 3 are only 1 and 3. It means we don't have P and Q that satisfy the requirement. P plus Q equal to 5 and PQ equal to 3 when you are looking at integer factors of number 3. Let's write that. No integer factors of 3 satisfy the requirement of P plus Q equal to 5 and PQ equal to 3. Does it mean that there is no root for this particular equation? Answer is no. We have roots for this particular equation. How do we know that? Let's say we plot the equation x square plus 5x plus 3 values for different values of x. Okay, you take x equal to 2, x equal to 1, x equal to 0, x equal to minus 1, minus 2, minus 3, minus 4, minus 5, and so on, and substitute them into the given equation and see given expression x square plus 5x plus 3 and see what is the value of that particular expression, right? When you do that, you get a curve like this, meaning when you tabulate those values for different values of x and then plot it, what you get is a figure like this. This graph says that there exist two roots for this equation. How do you say that? Because this particular curve is cutting through x-axis at 2 points, right? These are the 2 points. It means there will be two roots exist for this particular equation. One root, as you see here, it is lying between 0 and minus 1, and other root is lying between minus 5 and minus 4, right? Whereas when you tried using factorization method, since we were dealing with only integer factors, we were not able to find these roots which are in between different integer values, right? Now the question is, can completing square method is going to be of help in this particular scenario? Answer is yes. In these kind of scenarios, you get roots by using completing square method. Let's learn about completing square method so that you will know what are the roots of this particular equation, right? Let us understand the basic idea of completing square method now. X square minus 9 equal to 0 is a quadratic equation, right? It is in the form of ax square plus bx plus c equal to 0. where b is 0. That's why you have x square minus 9 equal to 0 as a quadratic equation. Got it? We can solve this equation by writing it as x square equal to 9, right? I have transposed this minus 9 to the other side. When I do that, I get x square equal to 9. I can take this power 2 to the other side so that it becomes square root. So I can write the equation as x equal to square root 9, right? Square root 9 is equal to plus or minus 3. It means x equal to plus 3 and x equal to minus 3 are the roots of x square minus 9 equal to 0, right? You can obtain the roots using the formula a square minus b square equal to a plus b times a minus b also. You try to solve using these formulas so that you will get x equal to 3 and x equal to minus 3 as the roots of the given equation, right? Now let us consider another equation. This is x plus 2 whole square minus 9 equal to 0. We can transform this equation into a quadratic equation, right? We have learned about how to do that. So when you transform this equation into a quadratic equation, you can apply split the middle term method and find roots of it. However, I want to try out something different here. X plus 2 whole square minus 9 equal to 0 can be written as x plus 2 whole square equal to 9, right? Now let me take this power 2 to the other side so that I can write the equation as x plus 2 equal to square root of 9, right? It means x plus 2 equal to plus or minus 3. Now I can transpose this plus 2 to the other side so that I can write the equation as x equal to plus or minus 3 minus 2, right? I can have two values for x. One is plus 3 minus 2 and other one is minus 3 minus 2, right? Let's take plus 3 so that I can write x equal to plus 3 minus 2, that is equal to 1, right? I can take minus 3 so that I can write x equal to minus 3 minus 2, that is minus 5. It means I have two roots for the given equation. Those are 1 and minus 5, right? As I said earlier, we can transform this equation to a quadratic equation and apply split the middle term method also, right? Let's do that now. When you want to transform this equation into a quadratic equation, you can expand x plus 2 whole square as x square plus 4x plus 4 using a plus b whole square formula, right? When you do that, you have the equation as x square plus 4x plus 4 minus 9 equal to 0. You simplify this. Plus 4 minus 9 is minus 5, right? I can write the equation now as x square plus 4x minus 5 equal to 0. Now we can split the middle term. For that, what we have to do is we have to find two numbers p and q such that their product is minus 5 and their sum is 4. You have now numbers 5 and minus 1, that is minus 5, right? Minus 1 plus 5 equal to plus 4. So with this, we can split the middle term, right? 4x can be written as 5x minus 1x. When you split the middle term, you can write the equation as x square plus 5x minus 1x minus 5 equal to 0. I can take x as the common factor from first two terms and minus 1 as the common factor from last two terms. When I do that, the equation becomes x times x plus 5 minus 1 times x plus 5. Now you see x plus 5 is common across these two terms, right? I can take x plus 5 as the common factor out now so that the equation can be written as x plus 5 times x minus 1 equal to 0. You have two roots. One is x plus 5 equal to 0, right? It means x equal to minus 5, right? And other root is x minus 1 equal to 0. It means x is going to be 1. So the two roots are x equal to minus 5 and x equal to 1. This is what we have obtained earlier also, right? But the approach is slightly different, right? In one case, we have expanded the given equation and transformed it to a quadratic equation. In other case, we have done it in slightly different way, right? Expressing, for example, earlier we are given this equation and we have transformed that to get this equation. Instead, for example, you are given this equation. If you transform that equation to this form to find roots of the given equation, then you call that as completing square method. Please understand this. Earlier, we are given this form and converted it into quadratic equation, this form, right? Instead, if you are given a equation in this form and if you convert that into in this form to find roots of the given equation, then you say that it is a completing square method, right? The idea is you adjust left hand side term of quadratic equation as a complete square so that you can find roots of the given quadratic equation in a simple manner. That method is called completing square method. We'll understand this further with the help of some examples, right? Let us find roots of 2x square plus 8x plus 6 equal to 0 using completing square method. When you look at this equation, you say that this is 2, this is 8, and this is 6. All these are multiples of number 2, right? It means I can divide each term of the given equation with number 2, right? Such that I can get coefficient of x as 1. Let's do that. When you divide each term with number 2, you get the equation as x square plus 4x plus 3 equal to 0. What I have done is I have divided every term with number 2, right, on both the sides. So the equation now becomes x square plus 4x plus 3 equal to 0. This equation can be solved using splitting the middle term method also, but here we want to use completing square method. For that, what I'm going to do is I'm going to rewrite this equation as x square plus 4x equal to minus 3. Now the idea is we want to express this x square plus 4x as a completing square, meaning as a complete square. For that, what we have to do, we have to first find out. You may have to add some number to this side and this side of the equation such that left hand side part is going to be a complete square, right? That's why the method is called completing square. So now you have the equation x square plus 4x equal to minus 3, right? I want to add something to this side and this side such that LHS of this particular equation becomes a complete square. Let's first learn about that. We know that a plus b whole square equal to a square plus 2ab plus b square, right? If I transpose plus b square to the other side, I can write the equation as a square plus 2ab equal to a plus b whole square minus b square, right? Now let's compare x square plus 4x and a square plus 2ab. If you want to compare straight away, it is a bit confusing. For that reason, let me write x square plus 4x as x square plus 2 times x times 2. 4 I have written as 2 times 2, right? Now you compare x square plus 2x times 2 with a square plus 2ab. When you do that, you say that a equal to x, right? And b equal to this particular 2, right? You have a equal to x and b equal to 2. Now let me substitute these two into this equation. When I do that, x square plus 4x can be written as x plus 2 whole square minus 2 square, right? Let me take a note of this. X square plus 4x equal to x plus 2 whole square minus 2 square, right? Let me transpose this minus 2 square to the other side, right? Then it becomes plus 2 square. It means the equation becomes x square plus 4x plus 4 equal to x plus 2 whole square, right? Now what you have understood is by adding number 4 to x square plus 4x, we could make it a complete square, that is x plus 2 whole square, right? What you have understood now, by adding number 4 to x square plus 4x, we can convert it to complete square, right? Now look at this equation, x square plus 4x equal to minus 3. Now, based on what you have learned here, you can say that I can add plus 4 this side and plus 4 this side, so that LHS of the given equation becomes complete square, right? Let's add number 4 to both the sides of the equation x square plus 4x equal to minus 3. When you do that, LHS becomes x square plus 4x plus 4 and RHS becomes minus 3 plus 4, right? Now we know x square plus 4x plus 4 equal to x plus 2 whole square. Let's write that. So x plus 2 whole square equal to 1, right? So now what I can do is I can take this power 2 to the other side, so that I can write x plus 2 equal to square root of 1, right? That is going to be equal to plus or minus 1. X plus 2 equal to plus or minus 1, right? Now I can transpose this plus 2 to the other side. When I do that, it becomes x equal to minus 2 plus or minus 1, right? Let me consider plus symbol so that x can be written as x equal to minus 2 plus 1, that is equal to minus 1, right? If I consider the minus symbol, then x can be written as minus 2 minus 1, that is equal to minus 3, right? Now x equal to minus 1 and x equal to minus 3 are the roots of 2x square plus 8x plus 6 equal to 0. You understood what we have done? We have written the given equation as x square plus 4x plus 3 equal to 0 first in the beginning, and then transpose this plus 3 to the other side, so that we could write it as x square plus 4x equal to minus 3, right? Then we tried to add something to both the sides of this equation such that LHS becomes complete square. For that, we have made use of a plus b whole square formula, right? Then we learned that by adding number 4, you can convert LHS into a complete square. That's what we have done, right? Then we have done some algebra to rearranging the equation such that we have arrived at roots of the given equation, right? Let us now find roots of x square plus 5x plus 3 equal to 0 using completing square method. You remember we couldn't find roots of this particular equation using factorization method, right? Now let's try to find roots of this equation using completing square method. For that, first let me transpose this plus 3 to the other side so that I can write the equation as x square plus 5x equal to minus 3, right? The whole idea here is we want to find some number which is to be added to both the sides of the equation such that the left hand side part of the equation becomes a complete square, right? That is the whole idea of completing square method. Now let's find what number to be added. For that, what I'm going to do is, let me make use of a plus b whole square formula. Sometimes you may have to make use of a minus b whole square formula also. But in this particular case, since x square plus 5x is there, since the plus symbol is there, I'm taking a plus b whole square formula. A plus b whole square equal to a square plus 2ab plus b square, right? Now let me transpose this plus b square to the other side so that I can write the equation as a square plus 2ab equal to a plus b whole square minus b square, right? Now let me compare x square plus 5x with a square plus 2ab. When you want to do it, when you want to compare 5x with 2ab, it is slightly tricky, right? Let me write 5x as 2 times x times 5 by 2, right? X square plus 5x is now written as x square plus 2 times x times 5 by 2, right? I have multiplied and divided 5x with number 2. That's how I have obtained 2 times x times 5 by 2. Now let us compare this x square plus 2x times 5 by 2 with a square plus 2ab. When you do that, you can say that a is equal to x and b equal to 5 by 2, right? Now let me make use of that and write this formula. A square plus 2ab equal to a plus b whole square minus b square, right? X square plus 5x is your a square plus 2ab. So a plus b whole square can be written as x plus 5 by 2 whole square minus b square can be written as minus 5 by 2 whole square, right? Let us take a note of this. When you look at this, if I transpose minus 5 by 2 whole square to this side, then the equation can be written as x square plus 5x plus 5 by 2 whole square equal to x plus 5 by 2 whole square. When you observe this, you can say that by adding plus 5 by 2 whole square to x square plus 5x, we could convert that to x plus 5 by 2 whole square, which is a complete square. Understood? We, by adding 5 by 2 whole square to x square plus 5x, we could convert x square plus 5x as a complete square, right? Let's do that. Let's add 5 by 2 whole square to both the sides of given equation x square plus 5x equal to minus 3. When you add 5 by 2 whole square on both the sides of the equation, the LHS becomes x square plus 5x plus 5 by 2 whole square. That is equal to minus 3 plus 5 by 2 whole square, right? This becomes now x plus 5 by 2 whole square, right? That is equal to minus 3 plus 25 by 4. 5 by 2 whole square can be written as 25 by 4, right? Now let us find the value of this. Minus 3 by 1 plus 25 by 4 can be now written as 4 is the LCM of 1 and 4, right? Now let me write minus 3 times 4 divided by this 1, that is 4, right? Plus 25 times 4 divided by 4 is 1. It means minus 12 plus 25 divided by 4, right? So let's write that x plus 5 by 2 whole square equal to minus 12 plus 25 divided by 4, that is equal to 13 by 4. Now what you have is x plus 5 by 2 whole square equal to 13 by 4. That can be written as x plus 5 by 2 equal to square root of 13 by 4, right? 13 is a prime number. That's why I'm writing it as square root of 13 only, right? And square root of 4 is 2, right? That's why we have x plus 5 by 2 equal to plus or minus square root of 13 divided by 2. Now, I can write it as x plus 5 by 2 equal to square root of 13 by 2. It means I have taken only plus symbol, right? It means I can write x equal to square root of 13 by 2 minus 5 by 2, right? Since denominators are same, we can simply write it as square root of 13 minus 5 divided by 2. X equal to square root of 13 minus 5 by 2 is one value. And if I take this minus symbol, I can write the equation as x plus 5 by 2 equal to minus square root of 13 by 2, right? That can be rearranged and written as x equal to minus square root of 13 by 2 minus 5 by 2, right? This plus 5 by 2, when it goes to the other side, it becomes minus 5 by 2. Now, since denominators are same, I can write it as minus square root of 13 minus 5 divided by 2, right? Let me take minus as the common factor, minus 1 as the common factor, such that I can write it as minus times square root of 13 plus 5 divided by 2, right? It means the roots of this particular equation are square root of 13 minus 5 divided by 2 and minus square root of 13 plus 5 by 2. Got it? let us note these roots. We know that square root of 13 is 3.6056. If you want to find the value, you can use calculator so that you can get it as 3.6056. Right? Now let's find what is the value of first root, that is square root of 13 minus 5 divided by 2. That can be written as 3.6056 minus 5 divided by 2, right? That is equal to minus 1.3944 divided by 2, that is equal to minus 0.6972. One of the roots is minus 0.6972, right? What is the second root? The second root is minus 4.3028. Now, you recall the graph we have drawn. We said that there are two roots for this equation, and those roots are, one root is lying between 0 and minus 1, and the other root is lying between minus 5 and minus 4, right? This is the root which is lying between 0 and minus 1. And this is the root which is lying between minus 5 and minus 4, right? What you have understood now by doing all this exercise is that completing square method is going to help you find roots that are real numbers, not just integers. In the case of factorization method, we could express the middle term and product of other two terms, coefficients, as product of two integers or sum of two integers, right? But when you are having some real number which is not an integer as the root of the equation, splitting the middle term method is very tricky. You don't get it because we don't know, how to get such factors, right? Even if you know that, it is going to be very tedious. So completing the square method is much easy to solve such equations. Understood? I hope you like the video. Please like, share and subscribe to our channel, Learn to Score. Thank you.